Hello and welcome to Physics Required Practical number 1, which is going to be all about specific heat capacity. Let's have a look at some of the equipment that you're going to be using. First, you're going to have a power pack, and you see that the power pack is set to DC, direct current, and is set to 12 volts. We have got 3 different types of metal block. You've got aluminium, copper and steel. You can see inside the aluminium block is an immersion heater. If you immerse something, it means you put it inside. So we can see that this heater goes inside the aluminium block, hence it is an immersion heater. We have got an ammeter and a voltmeter, a stop clock, some insulating material which we're going to wrap around the aluminium block in a short while to try and reduce the amount of energy that's dissipating into the environment. We have got a pipette with a small amount of water and a thermometer. One of the things that I really like about this practical is it gives us a great opportunity to revise one of the big 23 equations. P equals VI. Power is equal to potential difference multiplied by current. Now, in order to work out the specific heat capacity of these metal blocks, we need to be able to figure out how much energy has been transferred into them. And we can do that if we know the power, the rate of energy transfer of the immersion heater, and how long it has been switched on for. And the way we can work out the power of the immersion heater is to know the current that flows through it and the potential difference across it. We can then use power equals potential difference multiplied by current to figure out the rate of energy transfer, the power in watts of the immersion heater. Okay, let's see how we're going to use the equipment. So we've got a useful diagram of the equipment. We can see the 12 volt power pack. You can see the thermometer, the metal block. You can see this shaded area is insulating material around the metal block. This area here represents the immersion heater inside the metal block. And then you can see we've got an ammeter connected in series with the immersion heater and a voltmeter connected in parallel with the immersion heater. You can also see that I've now got the insulating material wrapped around the aluminium block. I'm going to take the pipette, I'm going to put a couple of drops of water into the hole for the thermometer, and then I'm going to put the thermometer into that hole there. Now, before I switch on the power pack and start heating up the aluminium block, I'm going to take an initial temperature reading, which is 25 degrees Celsius. I'd ask you to remember, when you take that initial reading, you should get your eyes level with the coloured water in the thermometer to make sure that reading's accurate. You record your initial reading on your results table, and then it's time to turn the power pack on. You should remember, when you turn the power pack on, to also immediately start the stop clock. Now you see, once the power pack's on, we're getting current and potential difference readings. And we don't need to take the next temperature reading until this gets to a minute. And so what you should do at this point is record your current and potential difference readings, because you're going to need those to calculate the power of the immersion heater. Those readings will not change during the course of the experiment. Once you've taken your initial readings, you can fill in this first results table. Now, I can tell you that the mass of all of the blocks, whether they're copper, aluminium or steel, is 1 kilogram. The current reading on our ammeter, you'll remember, was 2.88 amps. And the potential difference reading on our voltmeter was 11 volts. We can then use the equation, one of the big 23, P equals VI, to calculate the power of our immersion heater by doing 11 volts multiplied by 2.88 amps, which will give us 31.68 watts. And the unit of power is the watt. Once the stop clock reaches 1 minute, you're going to take a second temperature reading. Again, you need to get your eyes So the level of the coloured water, and that is currently at 26 degrees. So we've got an increase in just 1 degree Celsius. You'll notice I did not stop the stop clock to take that reading. It's essential that the stop clock keeps running throughout the experiment. What you're then going to do is take the temperature of the metal blocks every minute for 10 minutes or 600 seconds. I should warn you at this point that, of course, the immersion heater does get hot. So at no point during the practical should you touch the metal of the immersion heater. So this is our results table for the temperature change of the metal block. You can see we've got time in seconds down the left-hand column. We've got the temperature down the centre, and the work done, which is the time multiplied by the power, which we calculated to be 31.68 watts. So when we just started the experiment, the initial temperature was 25 degrees Celsius. After 1 minute, 60 seconds, the temperature had gone up to 26 degrees Celsius. And we could calculate how much energy had gone into the block by multiplying the time, 60 seconds, by the power, 31.68 watts. So remember, watts means joules per second. So 31.68 joules were transferred every second, which is why we do 31.68 multiplied by the 60 seconds that the power pack was switched on for. 1,900.8 joules. You will then complete the table for every minute up to 10 minutes, and you will be able to calculate the work done by multiplying 31.68, the power of the immersion heater, by the time in each row. Once you have calculated the work done, you are going to be plotting a graph of work done against temperature. So obviously we'd expect the temperature of the aluminium block to increase as we heat it up, and we can plot that against the work done in joules on the x-axis. We will then be able to use that information to calculate the specific heat capacity of the metal block.